mathematician. What's the significance of Charlie?
That's the constant of integration.
Okay, it's the constant of integration, a little bit more than that. What does that actually mean?
It just means for any value, for any constant, it has to be there. Because
For any constant, it has to be there. I don't know so much about that. But why is it that C could be any constant? Victoria, this was like yesterday when I was like, hey, does anybody know another function? How about another function? How about another function? Why can there be any constant here? Anthony, why?
When the derivative of C is found is equal to 0.
There you go, because you're taking the derivative in the check step, right? And if I've got a constant over here, it doesn't matter if the constant is pi, pi squared, square root of pi, doesn't matter. Derivative of a constant is going to be 0. We're good?
yeah.
All right, and this guy over here, everybody knows is a
Definite.
definite integral. And this guy over here means,
Area bounded by f of x.
right, this is like bounded area, and I'll just pretend that everybody knows all the rest of the stuff. Bounded area. Over here, bounded area, answer is a number. Over here, indefinite integral, answer is a function of some sort. Now, yesterday, you guys were like bumping into the walls all over the place, and somebody like, my smarticle particles have left me. Why don't I know any of these things? There are 13 formulas that I want to introduce you to and give you some time to practice with. I want you to go through, take 2 minutes. Which ones do you just know on sight? You just know. Anthony's already getting a couple of them wrong. He's going too fast. It's like no one ever introduced you to my friend Charlie.
Oh, I forgot about Charlie.
Don't forget about Charlie.
What kind of Charlie?
Don't, I don't know.
What's the derivative of E of X?
It's always interesting when the other calculus teachers are like, it's Charlie. I'm like, no, it's actually technically the constant of integration. They're like, oh, that's what you mean. It's like my friend Charlie. No. Haha, already took minutes. Man, I'm good. Okay. All right. I'll take anything from anybody, anyone that you know on sight. You just know it. Rogelio, give me one. Any of them. Okay, 2 is the natural log of x. That's what I heard you say.
Plus
Okay.
Charlie.
I'm sorry, what did you really say?
The natural log of the absolute value.
Natural log of the absolute value of x
Let's see.
plus Charlie. Well done. Okay. Can anybody explain why the absolute value bars now? Why? Why do I care about those absolute value bars? We weren't caring about them before. Tell me why.
You don't want any negative values?
We don't want any negative values. Tell me a little bit more. You're kind of in the right neighborhood. There's a problem with negative values in the natural log.
Oh, they don't exist.
I want to push for precision here.
Can
You guys draw the graph in the air? Graph of natural log. The graph of the natural log of x only exists here.
That's what I was
Your domain is going to be x values greater than 0, right? You cannot find the natural log of 0. You cannot find the natural log of a negative number unless you're going to allow complex numbers and Euler's theorems, and Demov's theorems. We're going to do all that post-calculus BC exam. Can't wait. When I ask you to find the antiderivative of 1 over x, there's no domain restriction here. This guy over here, that integrand works for all values of x except for 1. Except for 0. So there's only a domain restriction at x equals 0. If I don't put the absolute value bars, there's more of a domain restriction on the right than there is on the left. Just absolute value bars all the time. Memorize it if you have to. Okay, that was you. What else? There's 12 other ones. 12 other ones. Give me one you're frozen.
Number 3.
Number 3.
Square root of x plus Charlie.
Square root of x plus Charlie, because you know the derivative of the square root of x is
1 over 2 square root.
1 over 2 square roots of x. Good. All right. Good.
Secant squared The antiderivative of secant squared is tangent of x.
The antiderivative of secant squared of x is tangent of x plus Charlie. Yes, indeed, bonus innings there. Derivative of the tangent is secant squared. Yeah, I gotta know that one. You just wanna have that one on lockdown. No one wants to have to derive it in the middle of a test. What else? All my silent partners here who haven't gotten any of my loving yet.
Number 5.
Number 5, antiderivative of sine of x.
Cosine of x. Wait. Oh, antiderivative.
The antiderivative, right? And this is where things start to get tricky.
Negative cosine of x.
Is negative cosine of x plus Charlie. Okay, Nathan and, oh my God. Nathan and Victoria, haven't heard from you yet. Any of the ones on the board that you see that you know?
E over e to the power of x. E to the power of x.
Okay, antiderivative of e to the x is e to the x. I like it, but I don't love it.
Plus c.
Plus c, well done. Got some more. What else?
Number 4.
Number 4, antiderivative of negative 1 over x squared. You know that one?
1 over x plus Charlie.
1 over x plus Charlie. Great. I've got 6 on the board. That means everybody's back in the pool now. What other ones do we need to know?
Chepe, what do you know?
Hey, Chepe didn't know anything. Oops, sorry. Any other ones that we know? Everyone's back in the swimming pool. Get in while you can.
E to the negative x.
The antiderivative of e to the negative x is
Negative e to the negative x.
negative e to the negative x. Can you convince me why?
Because when you do the derivative of
Yeah.
that, you get e to the negative.
What? Yeah, that's not really an explanation. The derivative of e to the negative x is
Negative.
negative e to the negative x. So the derivative of a negative e to the negative x is negative e to the negative x, which is positive e to the negative x. Okay. Others? Get in there while you can.
The antiderivative of sine of k of x, k times x is equal to negative cosine of k of x
Negative cosine of kx
divided by k plus Charlie.
No,
divided
no,
by
no,
k
no,
plus
no,
Charlie. If you don't mind, I'm going to write it as negative 1 over k times cosine kx plus Charlie. Can you explain to everybody else why that works?
Because sine of k of x, no, cosine of k of x, k times x, should be a chain rule.
If I was going to take the derivative, so this would be a chain rule? Tell me about the chain rule.
After the derivative of cosine of x is sine of x, then you have to bring
It's what?
the derivative of cosine of k of x, k times x is sine of x.
What?
Sine
Still?
of k of x. Sine of
Oh
x.
my
I got it,
gosh,
I
man,
got it,
keep
I got it.
hearing him say that the derivative of cosine kx is
Sine
sine kx
times
k. I keep hearing you say that no matter how many times I say, what?
What?
The derivative of cosine is not sine. It
Negative
is
sine.
not sine.
negative sine.
It's negative sine of kx times k. So the reason for this negative 1 over k in front that I'm multiplying by, the negative 1 over k times negative sine kx times k, the k in the denominator, the k over here are going to cancel each other off. Negative, negative gives me the positive. All right, did I already give you one? Oh, your shirt's untucked. No, sorry. All right, other ones. Other ones, give me one.
Number 11.
Number 11.
Have negative 1 over k times sine k of x plus Charlie.
Negative 1 over k sine of kx plus Charlie, and how are we feeling about this one?
Because in the one above,
Positive.
And the antiderivative of cosine is sine, but not negative.
The antiderivative of cosine is positive sine.
It's gotta be positive.
So it's positive 1 over k. And are we okay with the reason for the 1 over k?
Yeah.
Okay, good. We still get a couple. So funny, the one that everyone's avoiding. Number 1. No one has actually talked to me about number 1 yet.
Brian, you got it.
Brian, you get it?
And then sine. Wait, hold on. Now I gotta think about it. Hold on.
Or balance.
Is it X was X of n plus 1 over n?
Like that?
Yeah.
Over n?
Wait, no.
Plus-
Never mind. Cancel it.
Okay, we're gonna cancel that order. Send it back. Okay, for all my folks that are struggling a little bit, antiderivative of x to the fourth.
1/5.
Oh, 1/5 to the x.
Right? If you have x to the fourth in front of you, it must have come from x to the fifth because we bring the power down. Okay.
How do you?
So,
So
if
would
it
it-
was, if I have x to the n in my integrand, the power rule, if I reverse it, is going to be x to the n plus 1
Over 1 over n plus 1?
times 1 over n plus 1.
Oh, here it goes.
Way to assist the funny looking kid with the poo in his shoes. So 1 over n plus 1, x to the n plus 1. Remember there was that problem yesterday where you guys did like, it was the antiderivative of like t to the 6th, and everyone was like, oh, 1/7 t to the 7th. And then the next part had like minus t to the 5th, and you're like, oh, minus 1/6 t to the 6th. There is a restriction here though. There's a restriction on n. There's one value of n that we can't use.
One.
One? No.
Oh wait, negative.
Negative.
Yeah, I meant negative one. Sorry.
Negative 1. So the restriction is that n cannot be equal to negative 1. So a question then might be, well then how the heck would I find the antiderivative of x to the negative 1? The antiderivative of x to the negative 1 is really,
1 over x.
so what's the antiderivative of 1 over x? Natural log,
Absolute value of x.
absolute value of x plus c. So this guy here is a special case. This is a special case of the power rule.
So they tie together in a way?
They're kind of tied together. This really is a power rule, but I can't use the power rule.
Yeah.
Okay, for some odd reason, we haven't integrated cosine of x.
Negative sign of x.
Oh my god, maybe that's why.
Oh,
The
sign of x.
antiderivative of cosine of x
That's twice I messed it
is
up now.
sine of x plus c. We also, for some reason, are skipping number 9.
1 over
Number
1 over k times e to the kx plus Charlie. Has everyone gotten enough lifesavers? Can I put them away?
I got like
Okay, good. So, oh yes, and
the check.
Mister, you got that.
I got this one, I've got this one.
That's
Secant of x plus Charlie. I just need you to know that the derivative of secant is secant of x times tangent of x.
Okay, I'll take this.
Okay?
I love that.
These, I would encourage you to memorize, make some flashcards. When the AD kids get here, we're going to be doing quizzes all the time. They're going to be like walking in the door, I'm going to be like, what's the antiderivative of x to the fourth? What's the antiderivative of sine of 2x? What's the da 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 da? For you guys, I'm just going to say a quiz on Monday.
This Monday?
What?
Yes.
What?
No?
Can we
How
make-
much advance notice do you need?
Can we make like a? Can we make a foldable like that?
Maybe I'll make a foldable with you guys. I'll think about it. Okay,
Because we made a
you've got
four.
6 minutes. Completely on your own. Forget what the instructions say. 6 minutes, show me what you can do. No help from anybody. Quiz before the quiz. in the event that you finish 1 through 8, feel free to try 9 and 10. Even more of a challenge. Keep your brain fit. Stop cheating. I see you. No, I said ignore what the instructions say and just do all 8 of them on your own. Cheater. Yes, I'm going to be very picky about the variables if you're integrating with respect to x. Don't switch it to t. And Brian, don't forget about a little guy named Harley.
Which Harley?
Less than 2 minutes left. Really? Okay, so that wasn't cheating, that was just getting notes.
Yeah.
Thought you were threatening Roger. Alright, why don't you check in with the folks at your group and make sure your answers match. I'm willing to talk about 1 or 2 of these if we find any that are just challenging for lots of folks.
Would you be like this?
Pie. Oh, that was a pie?
Yeah. Not a big piece of pie, right? How did you do this? Can I have to be like something like sleepy, like
On the yoga.
Yeah, my answers are up there if you want to check.
ooh. Okay. Okay. Oh, I put X for the left variable.
Uh-huh. Integrating with respect to t. How'd the first 6 go?
Wait, what's
Z.
final answer for number 7?
The final answer for number 7, I'd say 6 times the natural log of t plus pi times 1 over t.
Yeah.
Plus pi?
Plus pi times 1 over t.
If you add pi with t, same thing, right?
What do you think?
Yeah?
Yep.
Okay.
Pi times 1 over t, pi over t, same thing. Alright, so here's what I want to do. I want to put about 15 minutes on the clock. If you guys are all good with all 8 of these, I'll tell you you're in a good place for Monday's quiz. It is going to be a short, 8 to 10 minute kind of quiz. I need to make sure your skills are sharp. The best thing you could do this weekend is make sure that all 13 of those integration rules you have locked down. That you do not doubt them in any way, shape, or form. You got them under control.
Okay, can you explain number 7?
Well, if you've got them all memorized, then that's why you're going to be able to look at a problem like number 5 and say, oh, the antiderivative of 1 over 2 square roots of z has to be square root of z because I've memorized that before. Okay? You know, the reality is all 13 of these integration rules, you already kind of know anyway.
Yeah.
You just probably never expressed them that way. You expressed them in this direction. You say, oh, derivative squared of x is 1 over 2 square roots of x, but I need you to just get comfortable to say, oh, antiderivative of 1 over 2 square roots of x, square root of x. Okay? All right, here's what I want to do for 15 minutes. I want to just get some practice with some really tough algebra questions. So we're going to do 1 through 6, as many of those as we can. If you are feeling really good in the world of integration, just keep going. Just keep going. Don't wait for me. For those of you that just want to kind of hold my hand as we walk through the woods, we can do that too so that the big bad wolf doesn't get you. But at 4 o'clock, I'm going to shut it down so that we all move on to some application questions. Okay. So who are the folks that are with me on number 1? Okay. All right, so number 1, thoughts. My first thought is 1 over the square root of x is not actually one of the ones I've memorized. Right? It's not on that list of 13. Neither is the cubed root of x. But there's some stuff I can do. Legal algebra stuff that I can do. Maybe you see 1 over the square root of x and you say, oh, well, isn't that really the same as 1 over x to the half? Cubed root of x, isn't that really the same as x to the 1/3? I'm integrating with respect to x. For the folks that are with me, are we okay that that's legal? Be really careful with your notation. I haven't found an antiderivative yet, so I'm still going to write this. I'm still doing things with respect to x. 1 over x to the half isn't in that table either. But another legal thing that I can do is rewrite this as x to the negative a half and leave that guy there as x to a third. And now there is an integration rule that I can apply.
First one.
It's the first one. It's the power rule for integrals, right? This guy here, if it's x to the n, the antiderivative, you guys told me, would be 1 over n plus 1, x to the n plus 1. So in this case, the n is negative a half. So when I find the antiderivative, I'm not going to write the integral sign this time. It's going to be x add 1 to the power. Negative 1/2 plus 1. What is that, positive a half?
Mm-hmm.
And then in front, 1 divided by a half. Plus, power rule again, I've got x to a power. Power rule says add 1 to the power, x to the 1/3 plus 1. What is that, x to the 4/3? And then 1 divided by 4/3 plus Charlie.
That's why we have to memorize it.
That's why I want you to memorize it so that you can just apply it as many times as you can. Questions about what just happened here? We're okay with the power rule? Okay. Clearly this is not going to show up in the multiple choice. You will never, ever, ever see that I have typed an answer that looks like that. Legal things that I can do to hide this from you include flipping. What am I flipping? Because I cannot do a flip. It'll end badly.
So 1 times 2 over 1.
Right, 1 divided by a half is the same as 1 times 2 over 1, so I'm just going to write this as 2x to the half, plus over here 1 divided by 4/3, is that 3/4, x to the 4/3 plus Charlie. I like that. That could show up as an answer. Probably won't. Brian, what else am I going to do to hide this from you?
Instead of Charlie, put something like 20.
Okay, right, maybe it's not plus Charlie, maybe it's some other constant. Other things that I could do to hide this from you on the multiple choice part. Think, what are all those tricky things that I always do with my algebra skills? Take the fraction. What do you want me to do with the fraction?
The exponent fraction and put it in.
Right, that fractional exponent, instead of saying x to the 1/2, the other way I'm going to write this would be 2 times the square root of x plus, instead of 3/4 x to the 4/3, I could write this as cubed root of x to the 4th plus Charlie. That's another legal thing I could do to hide this from you. Okay. All right, I'll call that one good. See what you can do at number 2. He left y'all behind.
Oh, you're doing the same thing you do in physics.
What's the same thing he does in physics?
He just goes on the notes and just like finishes the whole thing.
And that just feels so wrong to you because you still want me to tell you where to write the
Just
things.
go, just follow the class, man. That's why you're here.
No, he's okay. It's okay. God, you're such a rule follower. If you weren't too old, I'd say you should date my daughter because she's such a rule follower.
I mean, that's not.
Oh, shut up. Number 2 clearly does not fit any of the integral forms yet. So Nathan, what are your thoughts here?
It's a factor out.
Okay, tell me what you're doing. What's this legal math that you speak of?
Let the factor out x.
Okay, you can factor an x out of the numerator. So now I've got x times x plus 4 over x squared dx. How does that help you?
Cancel out.
Ah! Now I've got an x up here, and I can cancel with an x down there. But now that still leaves me x plus 4 dx, and depending on how I'm seeing this problem, that still doesn't help. Right? I'm not at a place where I know exactly what to do. What other thoughts are out there?
Yes, Charlie wants to.
I was gonna do x squared over x squared plus 4x over x.
So Brian, you're saying you want to do x squared over x squared plus 4x over x squared?
Yeah.
Victoria, what are your thoughts on what he wants to do? X squared over x squared plus 4x over x squared. Would that be legal?
Wait, what, you said x squared over?
X squared divided by x squared plus 4x divided by x squared. Would that be legal?
Yeah, you can separate.
Yeah, I can separate one fraction into 2 as long as I do it well. Okay. Now I could also do that over here with what Nathan did, right? Nathan saw common factor of x and it cancels, and that's a little bit better, but I'm still not done. So let me rewrite this and say that's x over x plus 4 over x dx. X over x is really 1. Now, a place where a lot of times the AB students start to kind of struggle a lot is this 1. They're like, I know what the antiderivative of 1 is. They're going to tell me that the antiderivative of 1 is 0. But what they're really thinking is derivatives, not antiderivatives. The antiderivative of 1 has to be x. Plus, another place where, golly, oh, we're on the struggle bus. 4 divided by x. They think it's going to be like some strange other version of the natural log. We're not laughing at them. I'm just telling you, like, this is a place where they struggle. But if this was 1 over x, everybody would tell me that the antiderivative is natural log absolute value of x. So if it's 4 over x, it's 4 times that amount. So it's going to be x plus 4 times the natural log of the absolute value of x plus Charlie.
It could be even better to just put the x to the power 4.
And if I'm truly being evil, if I'm channeling my inner tough guy here, I'm going to hide this from you in the multiple choice as well. Lucia, what is it that you wanted me to do?
Instead of 4 times natural log of x, you put natural log of absolute value of x to the power 4.
Right, it's that reverse p in front of the log. With the natural log of something to a power, you can bring the power down, but that also means you can bring it back up. I think that would be a little sick and twisted,
Lucia.
but you know, it could work. I could even go crazier than that and not write the absolute value bars.
No, right, but what?
Why is it okay to get rid of the absolute value bars? You're first. Why can I get rid of the absolute value bars and it's okay?
To the fourth.
Because I'm raising it to the fourth, so what?
Or will we be positive?
No matter what the x value is, it has to be positive now because I'm raising it to the fourth power. I don't need the absolute value bars to do that. That's a place where I could legally get rid of it. Pretty good? Good. All right, I'll take that as the universal sign for yeah. All right, I'm going to let you guys play around with 4 and 5 for a little bit.
Oh.
Because according to Lucia, distribute this too.
Oh, you didn't realize it?
No, I did.
Not making me feel And you're right, 4 and 5. Because actually number 3 we did yesterday.
Oh.
Although oddly enough, you're doing the same thing you tried doing yesterday.
Could we do 4?
4 and 5. I figured you guys would just remember the answer from yesterday. Why doesn't this work?
I mean, this is a, what do you call it?
1/2 x.
This is a chain rule.
Yes. So if you were to take the derivative of this, how would you take the derivative?
Derivative of this.
Yeah, derivative. If the indefinite integral is this, then that means when you take the derivative, you get back over here, right? What happens if you were to take the derivative, you'd use the chain rule. You'd say it's 1/3, taking the derivative of 1/3 stuff cubed. Bring the 3 down in front. 3 times a third is 1, that's a good thing. Times all this to the 1 less power, to the 2. That looks good. You've got to take the derivative of what's on the inside.
I thought this derivative was
Chain rule. If you're gonna find the antiderivative, you've got to think if this is the answer, then I should be able to go backwards by taking the derivative. But if you take the derivative the right way, which involves the chain rule, you won't get this back. You'd get 3 times a third 1 times all this squared times the derivative of what's on the inside, and that's not what you have. Okay. All right, Nathan, give me some clever stuff here for number 4. What are you thinking?
Multiply x and the square root of x.
X times the square root of x. What's that going to get you?
X times x to the half power.
Okay, good. Thank you for breaking it down. So you'd say it's x times x to the half power. And then maybe over here, x to the 2/5 power dx. So x times x to the half power.
X to 3 over.
X to the 3 over 2. And x to the 2 over 5 power. Right. Antiderivative of x to the 3 over 2 power. This is that power rule again. The antiderivative of x to a power. What do we do?
Oh.
If I'm trying to find the antiderivative of x to the 3/2 power, that power rule.
1 divided by n plus 1 times.
All right, the antiderivative of x to the n is we add 1 to the power and we divide by the new power.
Mm-hmm.
So in this case, my power is 3/2. So I'm going to have x to the 3/2 plus 1, which is 5/2. Now, I would imagine a lot of us are going to get to the point pretty quickly that you don't want to write 1 over 5/2 anymore. Probably just going to go straight to 2/5.
It's gonna be
Okay. This guy over here, antiderivative of x to the 2/5, well, add 1 to the power, it's going to be x to the 7/5. 1 divided by 7/5, 5/7.
Wait, what?
Plus Charlie. Don't forget about Charlie.
I thought it was divided by n plus 1.
You're right, it's dividing by n plus 1. The n is 3/2, 3/2 plus 1 is 5/2. But 1, I could have written this as 1 divided by 5/2.
Yeah.
But 1 divided by 5/2
Oh, okay,
is
okay.
2/5.
Okay, that, because I wrote it the way you had in the orange.
I understand, that's fine. Okay. What about the thoughts on number 5?
I took out the fractions out.
So you took out the fraction, what do you mean?
Like for x over 4, I did 1/4 times x.
Okay, so you're gonna write this as 1/4 times x, is that legal?
Yeah.
I think that's legal. Okay, plus, how about 4 over x?
4 times x to negative 1.
Okay, you could write it as 4 times x to the negative 1. For some crazy reason, I'm gonna encourage you to leave it as 4 times 1 over x. Just let me be a little cray-cray. And 4 over x squared.
4 times 1 over x squared.
Okay, maybe you write that as 4 times 1 over x squared. Now that's just rewriting, that's not the final answer, right? We're just playing around with this, giving it a little massage. One thing you might want to do, depending on your comfort level, if there are parts of this integram that you're like, oh, I know exactly what to do, but then there are other parts that you don't, let's break this up. Instead of writing it as one integral, I'm going to write it this way. The antiderivative of 1/4 x dx plus the antiderivative of 4 times 1 over x dx plus the antiderivative of 4 times 1 over x squared dx. First of all, is that legal? This ought to look familiar. We've played this game before. Can I take that integral and just distribute it to each of the 3 terms? That was one of those properties of definite integrals that we had a chance to play around with. Great. The advantage now is if I said, hey, how do you find the antiderivative of 1/4 x? That 1/4 is a constant that you're multiplying by. There's another nice property when it comes to constants. I can pull it out in front of the integral to just say this is 1/4 the integral of x dx. Plus that 4 is a constant, I can pull that out in front. 4 times the definite integral of 1 over x dx. Plus, oh, that 4 is another constant, 4 times the definite integral of 1 over x squared dx. The antiderivative of x, that's what we need to know. Antiderivative of x.
1 over 2 x squared.
Right, this part here should be a half of x squared,
Oh,
so
yeah.
it'll be a 4th times a half of x
So wouldn't
squared,
that just be an 8?
which is actually an 1/8, but I wanted to make sure we see where that 1/8 comes from. Plus, how about 4 times the definite integral of 1 over x?
4 times natural log.
Yeah.
Right, that should be 4 times the natural log of the absolute value of x. Plus 4 times, this one's a little bit tricky.
Negative 1?
Negative 1 over.
It's going to be negative of 1 over x.
So would it just be minus 4?
Yep, so if I wanted to clean this up, I'd say it's 1/8 of x squared plus 4 times the natural log of x minus 4 over x plus Charlie. Okay. All right, so rather than just keep beating you up with the algebra stuff, the hardest thing that we're going to encounter in this unit with antiderivatives is just knowing what to do and when to do it. I want you guys to pick at least one application question. If you are needing to feel really good about yourself right now, I would encourage you to find a partner and work on questions 1, 2, or 3. These should be ones that make you feel pretty good. If you want to see just how high the ceiling can be, try 4, 5, or 6. I've not had a chance to work through 4, 5, or 6 yet. This morning when I went searching for extra challenging problems to feed your brains, I thought, yes, 4, 5, and 6, these look good. And if for some reason you're already done with them, I'm gonna stop lesson planning and just let you do all the rest of it for the rest of the year. Okay, so you guys tackling numbers 1, 2, 3? You're not gonna get through all of them in the next 5 minutes.
I know.
Okay? Did you factor in, cancel, and reduce? Yes. Yeah. Now you have to find the antiderivative. So what would give you a derivative of negative x? Squared, good. Plus, what would give you an antiderivative of 2? Oh, yeah, no, you're right. Okay. So you're doing, which one are you doing? Okay. I got you. In case this job doesn't work out, I could try to be a waiter. Actually, I hated being a waiter.
Do we need to find the indefinite?
Yeah, I'm gonna do number 1.
Go ahead, I already know one.
Am I right, number 1?
I don't have solutions for 4, 5, and 6.
Wait, so am I in the right step for like changing this into this?
Maybe. Hey.
Can you do that in Word?
You guys haven't struggled enough.
Number 6?
Hey, you haven't struggled enough. It's been like 30 seconds.
Okay, so this is
So what are we doing with this first one?
Where you gave me How you feel about Charlie?
Do we have to find Charlie?
That's why I gave you this extra information.
So
But I'd call this big F. Or, I'm sorry, little f. Little f of x. Not f of 0 yet.
what is this?
Right, so f of x is negative 1/2 cosine 2x plus 3x plus Charlie. And now, because I gave you this extra information, now you can plug it in and you can figure out what the value of Charlie.
Oh, no, you have to find the first
But it's not execute. So I'm picturing it like this. It's like half a parabola going up and half a parabola going down.
X cubed has the same behavior. But what's the derivative of
The
x
0.
cubed? 3x squared, not this. So, you get
Now, what do you mean square root? This is just x.
Yeah.
you're
I think when I'm feeling great about myself. Because I find Charlie.
actually no, you're wrong. You're right.
What is that? How you can find Charlie?
So this here has a domain restriction. The way you've chosen to rewrite the absolute value of x, there's no domain restriction on from your perspective, the left-hand side of the equation. But on the right-hand side, there's a domain restriction. What's the domain restriction?
Like 0 or 0.
No,
Right, greater or equal to 0. I can take the square root of 0.
I thought it was.
So these are not actually equal to each other. They're not completely equal to each other because there's no domain restriction here, but there is a domain restriction here.
But when you use imaginary numbers,
Right, but the issue is you still can't say they're equal because of the domain restriction.
okay.
This variation of force.
A way that you could say you write it as the square root of x squared. Because now whether x is positive or negative to begin with, once you square it, you get 0 or a positive number, and you can take the square root and get same thing as the absolute value. There's another one, because we still won't know how to find the antiderivative of this. There's another way. If I think about the graph of the absolute value of x,
You're doing everything.
Yeah.
there's another way
I
to
wasn't
think
even paying
about
attention to it no more.
As a piecewise function?
right? You could say, let me think about this instead. Well, what are the pieces?
So
Would
the
it
one
just be a,
going towards, the one on the left
The one on the left.
should be negative 1/2 x squared.
Well, the original function is negative x.
This is double derivative.
And over here, it's x. So you've got negative x or x. X if x is negative. Positive x if x is greater than or equal to 0.